Good day everyone. So today we will be discussing generated EMF of a DC generator. In order for us to solve the generated EMF of a DC generator, we will be using the Lenz's law formula. That would be E. E stands for the generated EMF is equal to number of poles, number of flux, the speed, and the number of conductors divided by 60 times the parallel path. Once again, P stands for number of poles. This is the flux per pole. N stands for the speed of the armature. Z stands for number of conductors. And A stands for parallel paths. There are two types of winding. We have the lap and we have the wave winding. For the lap winding, we will be using this formula for the parallel paths. A is equal to the multiplicity multiplied to the number of poles, and for the wave winding, we will be using A is equal to twice the multiplicity. There are things that we need to consider before we solve the generated EMF of a DC generator, and these are the SI units. To solve for the generated EMF, the flux must be in Weber and the speed must be in RPM, or stands for revolution per minute. There will be instances where we will solve a problem that the given flux is in Maxwell. However, we need to use the SI unit. So to convert Maxwell into Weber, 1 Maxwell is equivalent to 1 times 10 raised to negative 8 Weber. And there will also be instances wherein the given problem use revolution per second. So always take a note that flux must be in Weber and speed must be in revolution per minute. So let's try to solve a problem. Okay, so this is a problem. A 4-pole DC generator with duplex winding, lap winding, has 48 slots and 4 elements per slot. The flux per pole is 2.5 times 10 raised to 6 Maxwell, and it runs at 1500 RPM. What is the output voltage? Output voltage is the same with our generated EMF. Again, our formula. Okay, how many poles do we have? Let's write down the given. There are 4 poles with a flux per pole of 2.5 times 10 raised to 6 Maxwell. The speed is 1500 RPM. And our number of conductors. So let's look at the problem. It says here that there are 48 slots, and each slot there are 4 elements. So 4 times 48, that would be 192 conductors. And for the parallel path, since this is lap, we will be using M times P. To know the multiplicity, if this is a duplex, it means that there are 2 multiplicity. And if it says simplex, 1 ang kanyang multiplicity. So this is 2 times number of poles, 4. We have 8. So to solve this problem, we have 4 times 2.5 times 10 raised to 6. Let's multiply that 2 times 10 raised to negative 8 to make it Weber times 1500 revolution per minute times 192 conductors divided by 60 times 8, and the answer is 60 volts. So this is the final answer.